Welcome to today's lesson. We are going to look at area. By definition, area refers to the measure of surface. The SI unit of area is square meter. Remember, area is a derived quantity, and that is why we are squaring the units of length. It is derived from length. So we have multiples and sub-multiples of square meter. And for us to get the multiples and sub-multiples, it is important to write as follows. If you have 1 square meter is equals to 1 meter times 1 meter. But we know that 1 meter is equals to 100 centimeter. So this will be 100 times 100. So when you multiply 100 by 100, you get 10,000. So it implies 1 square meter is equivalent to 10,000 square centimeter. Again, you can proceed like that. Now, in this case, we want to get it in square millimeter. So you have 1 meter is equivalent to 1,000 millimeter. So you multiply 1,000 times 1,000, you get 1 million square millimeter. So 1 square meter is equivalent to 1 million square millimeter. Similarly, you can do the same and get that 1 square kilometer is equivalent to 1 million square meter. So we are going to use this in our conversion of units. So we proceed with conversion. We have an example. Express the following in square centimeter. Part 1, we have 8.5 square meter. Part 2, we have 0.09 square meter. And finally, we have the third one in square kilometer. So we proceed as follows. Start by writing the equivalence. And note, just as we have done in length, always make sure that the units that are similar are on one side. So we have 1 square meter is equivalent to 10,000 square centimeter. What about 8.5 square meter? So we cross multiply. After cross multiplication, we have that 8.5 you are multiplying by 1,000. Then 1 square meter you are multiplying by x. So to get our x here, remember we are multiplying. To get our x, we divide. We do the opposite. So divide by 1 square meter. The units will cancel out. You are left with values 8.5 times 10,000. When you multiply, you get that it is 85,000 square centimeter. Then we proceed to the second one. We start by writing our equivalence, which is 1 square meter is equivalent to 10,000 square centimeter. Again, you write the units that are similar on one side and then you cross multiply. After cross multiplication, you find that 0.09 is multiplied by 10,000, and on the other side we have 1 square meter being multiplied by x. Now again, to get the value of x here, you need to divide. We are multiplying, so we divide. By division, we need to cancel out the units. So you have 0.09 multiplied by 10,000, you get that it is 900 square centimeter. Then finally, proceeding as the previous ones, you will find that after cross multiplication and getting the value of x, you get that this value will be 8,000 square centimeter. We continue with another example. Express the following in square meter. We have the first one 7,000, the second one 0.05. So we proceed as follows. We start by writing our equivalence. Then we write the units that are similar on one side. We cross multiply, and then finally we get the value of x. Remember, we are multiplying here, so we divide by 1,000. And make sure that you show us how the units are cancelling out. And finally, you have your units or your values cancelling out. Remember, you are just left with 1 unit here, square meter. So after dividing 7 divided by 10, you get 0.7 square meter. Then in our second case again, we start by writing our equivalence, which is 1 meter squared is equivalent to 10,000 centimeters squared. What about 0.05? You cross multiply. After cross multiplication, we have x multiplied by 1000 is equals to 1 multiplied by 0.05. Now to get x, I insist, whenever you see multiplication, to get the value of unknown, you always do the opposite. And the opposite of multiplication is division. So you divide. And then finally, you show us how the units are cancelling out. And then you find your value using the correct symbol. Measurement of area. We have that the area of regularly shaped object, this one, you can obtain the area by using the appropriate formula. For instance, we have rectangle. Rectangle, the area is length times width. We have circle. For us to get the area, we get that it is pi r squared. And the radius, you can get radius if you are given the diameter, where we say that radius is diameter divided by 2. Then we have triangle. For us to get the area, we have a half base times perpendicular height. It is clearly indicated in our diagram. Trapezium, it is a half multiplied by the sum of parallel sides. In our case here, the parallel sides are indicated as A and B. So it will be A plus B, then multiplied by height. Then we move to the area of irregularly shaped surfaces. And for us to get the area of irregularly shaped surfaces, first of all, we subdivide that surface into small equal squares. Then you're supposed to determine the area of that one square, and then you proceed as follows. The area is given by 1 number of complete squares plus a half number of incomplete squares, and then you multiply that sum with the area of one square. We can look at an example here. You have the diagram here, and you're supposed to estimate the area of irregular shape as shown in this diagram. So we've said the first step is to subdivide this surface into equal squares, and we've done that. Then after that, count the number of complete squares. If you look at my diagram here, the number of complete squares are 1, 2, 3, and 4. So I have 4 here. Then we count the number of incomplete squares. We are starting from here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. So we have 22 incomplete squares, and we have said that you get the half of that. So the half of 22 is 11. And then finally, after adding, you are supposed to multiply by the area of one square. The area of one square is given as 1 square centimeter. So in our case here, we have 11 plus 4, you get 15, then multiplied by 1, you get that the area is 15 square centimeter. Then we proceed to examples. A sheet of paper measures 20 centimeter by 15 centimeter. Calculate the area in millimeter squared. You can approach this in 2 ways. You can start by changing or converting the units of length into millimeter, then you get the area. Or you can get the area and finally you convert the area into millimeter squared. So we start by getting the area. The area is length times breadth, that is 20 multiplied by 15, you get 300 square centimeter. Then convert the area into square millimeter. We have that 1 square centimeter is equivalent to 100 square millimeter. So again, we proceed the way we've done area, cross multiplication and getting the value of x. Finally, you have your units cancelling out. So you have that in terms of square millimeter, the area of that sheet of paper is 30,000 square millimeter. We have another example here. You have that the diameter of a test tube is 10 centimeter. Calculate the cross-sectional area of the tube in square centimeter, and you're supposed to use the pi as 3.142. Remember, we are given the diameter. So we start by writing the formula. We start with the formula always. Our cross-sectional area is circular. So the area is the area of a circle, which is pi r squared. But we are given the diameter. To get the radius, we get the diameter divided by 2, we get 5. So we multiply, this is our pi, times 5 times 5, you get that the area is 78.55 square centimeter. Then we have a quiz. Quiz yourself. We have so many questions here. You are supposed to calculate, others you are supposed to estimate the area. So make sure that you practice a lot, and before you attempt your quiz, it is always good to revise on your video to ensure that you are able to get all the concepts. Finally, practice and ensure that you get the correct answers. Thank you, and let us meet in our next lesson.